Hi, I'm John Russell, editor of HPCwire, and with me today are two very distinguished members of the broad computing. You guys have been in just about every piece of the computing world. Bill Gropp is the Thomas M. Siebel Chair in Computer Science at the University of Illinois. I hope I got that right, Bill. And Thom Sterling, professor this is new, Thom, this is a new initiative, professor in Intelligent Systems Engineering, as well as the chief scientist at CREST. Did I get that right? Okay. I thought today, since you've both written on this in HPCwire, the National Strategic Computing Initiative, I thought we would ask or answer a few questions around that. There was an update yesterday that I went to. I think there was a panel. I missed the panel, unfortunately. But I wanted to start, with something pretty straightforward. The implementation plan is due out soon. I believe it's been drafted, but it's not been shown publicly yet. It will be maybe in the February timeframe. What are both of you looking for from that implementation plan?
Well, I think one of the first things I'd like to look at in the plan is where the funding is going to be coming from and what are the level of investments. Particularly, where is it going to come from? Is it going to be coming out of research? Is it going to be coming out of the production side? What is that balance going to be? So I want to understand how the allocation of effort like that. The other thing is it's really important that we get to a system that can deliver workable systems for the scientists. So I'd love to see an implementation plan that both pushes on the software and the algorithms to address some of the issues, but doesn't go overboard and say, we'll throw everything out and start from scratch. I'd love to see something that accepts the fact that there's a lot of technology that we have which has not been applied to applications, and that by putting a little more effort into addressing maybe some of the engineering issues, some of the open research issues, we'd be able to take that and address some of the software issues without essentially starting over. So I'd like to see a very pragmatic approach to the software and the implementation plan.
So first, I think the most important thing for NSCI to be successful is to actually follow the charter that's specified in the President's executive order, and that is to recognize a true community approach to the achievement of exascale. And that's not just exascale compute intensive, that's also exascale by some measure of data centric, advanced data analytics, and indeed machine learning. I would also like the NSCI program to focus on the integration of efforts at research and development, at academia and industry, as well as the end users such as, but not limited to, the national labs. So, in fact, my first goal for NSCI is to fulfill its stated goals and objectives. My second concern, and I differ with Bill just a little bit in emphasis, not in important points, but that I am concerned about problems within the goals of achieving true exascale and beyond that have yet to be addressed for some classes of applications. While, in fact, I fully agree with Bill that other forms of application, which includes much of the existing national inventory and investment in legacy codes, that they are being or will be satisfied with incremental changes of existing methods and therefore provide a cost-effective way and a lower risk way. But I believe that there is also the necessity at a slightly higher level of risk perhaps and slightly more cost over a long period of time, but that there are challenges that ultimately have to be addressed under NSCI. And I'm very excited about the executive order and the opportunity of defining this as a national objective.
And one of the points you both bring up, or I guess imply, there's this set of expectations and hopes. To make that happen, there has to be an effective outreach to the community, both industry and the academic community. I'd love to get your thoughts on how effective do you think it's been so far, and are there things that haven't been done that maybe should be done in terms of that?
This outreach is, of course, very difficult, and there've been a long series of projects at different levels, various sorts of public-private partnerships. DOE in particular has had a sequence of those trying to push forth the technology. I think that there's a real opportunity here, though, to think more about an outreach into the applications communities, into the scientists who are using the systems, because we see a big gap, particularly in the areas that Thomas alluded to, the sort of the usual suspects. Those people are well aware of the directions the architectures are going on. They've got good programming systems, but other places where high-performance computing, exascale computing, could really lead to a revolution, are not as cognizant of what this computing is like. I work with scientists in some other areas, and I'm not going to say what they are because I don't want to embarrass them, but they're basically stitching codes together with scripts. And we need an outreach to them to bring them into this process. Co-design, again, has involved the usual suspects. It really hasn't brought in the others. So that's the sort of outreach that I would be looking for, not the ones that we've been doing fairly well between the vendors and the government, but I think between the application areas, the academicians who are developing new techniques, the vendors who are going to have to support them, and the government is going to have to pay for them.
Again, I fully agree with Bill, but I'd like to say that I think the term and the projection of outreach is the wrong approach because it suggests a first-class core community and then outliers. And what I think is needed and what I'm hoping NSCI will catalyze is a redefinition, a reinvention of community where the power, the strengths, the expertise, the experiences, the perspectives of the diversity from the labs as a user group, from industry as a user group, from the developers of systems recognize that they're moving towards new systems. For those who are looking at, well, forgive my use of the term, but alternative execution models and approaches, however that evolves, either from incremental changes of past practices or not throwing out everything, Bill, but remembering some of the ideas that existed 20 and 30 years ago and applying them to our needs. So I would say community building rather than outreach is the right perspective on that.
Part of the plan, as you've noted earlier, is to create an ecosystem that involves industry. How is that different from what we've discussed now? In terms of building a bigger community without outliers, industry's needs may be a little different. They're not as involved in, let's say, some of the code development, and yet they're going to need to use it if we're really making this happen. What are your thoughts around that? Is there a different way to engage with industry and with the people within industry who will be using these tools?
Well, I think that one of the issues that industry faces is that while some of them very much do have current petascale problems and have exascale problems, a lot of the work that they're doing is a step down from that. And so they're not looking at the larger systems. Now, there's a lot of commonality. Directions are moving there, but I think that is, in fact, one of the reasons why a lot of people may look at NSCI and say, well, it's great leadership in high-performance computing, but I'm not doing that. And in fact, the recent PTAC update, even though it came out before the NSCI, specifically raised this as a concern that the NSCI focusing on the very high end, it doesn't downgrade the mid end. It just doesn't say too much about it. I think that communicating that and the fact that there is, in fact, a tremendous overlap in the algorithms that you're going to be using, the techniques, the new programming models, the approaches, just because the high-end systems are going to get the parades, the flash. A lot of the techniques that are developed there will either be directly applicable or will quickly filter down to the smaller systems. Smaller systems meaning teraflop systems, petaflop systems, right? And so I do think communicating that, letting the industry understand that not only should they be looking forward to that coming down, but they in fact have a lot to help us with in terms of understanding how to move up. And because often they have challenges that would push us to improve our algorithms, our programming models, our communities, so that they're not working in such an isolated way. I'm really glad that Thomas mentioned that. So I think that that's one of the things that we should be looking for as well.
To understand this particular challenge, we have to recognize what industry's objective function is. And this is economic incentivization, competitiveness, and return on investment. And we have done a disservice, we the entire community, by defining the total space as computing and high-performance computing. It's ironic because original computers were the high-performance computers, and more conventional or smaller computers were spin-offs of high-performance computing. But by creating this separate group, this separate mentality or perspective, we've allowed managers to look at their budget, their spreadsheets, and say, no, we don't do high-performance computing. We should be about computing. And the best computing, because computing is about performance. Otherwise, you'd use a slide rule and pencil and paper. So what we have to do is recognize, as Bill is alluding, to the computational challenges of the end problems, whether they're engineering or process control or even broader societal data analytics, and use that as as drivers, the breadth, no single operating point, but the drivers towards the challenges of efficiency and scalability.
Thanks, Thomas. So I know, guys, you have tight time schedules here. So a question I did want to ask to both of you was, so I've talked with a lot of people about the NSCI. We're trying to champion it, and so we monitor the response of the audience to these things. And it seems like the response from leadership positions is quite strong. So I've talked with Pete Angaro at Cray and elsewhere, within IBM and Intel, and at the leadership level, they're all excited about it. If you go down to people who are actually using higher-end computing to do their jobs, they're not really, it's not on their radar screen. Is that a good thing or a bad thing? What is it? Does it need to change? What are your thoughts on that? That it seems like the leadership in general is excited more so than elsewhere.
Well, I do think it's a bad thing that the excitement is not so pervasive. I think part of it is that we've been waiting for national leadership on this for a long time. And finally we got it. So people who are looking for that leadership are now thrilled, and they're expecting a lot from the implementation plans and from the cooperation that the executive order requires. But the people in the trenches have got to deal with problems now, and there's no new funding with the plan, so there's no immediate access. It's unclear, because there's no implementation plan, what's going to emerge first out of this. So I do think that there's a need to really get the people in the trenches, the people who who depend on computing, the people who are advancing the computing, both to see what the NSCI is giving us in terms of leadership, but more importantly, they need to be participating. Now, it will be interesting to see what the response to the RFI, that is maybe one of the first acts of the NSCI, from the scientific community in terms of what that community is looking for from the NSCI. We may be surprised to discover that a lot of people really are excited about it, and maybe they will help spread the word.
Absolutely agree with Bill, and yes, especially about the hunger for leadership. We're facing one thing we have to be clear on is there is a degree of healthy skepticism in the community without a budget, which in some sense defines a degree of commitment. It's hard for individuals to be totally engaged and excited. But there's another aspect of this, and Bill alluded to it. It is that for different parts of the community exist on different sizes of the event horizon, the goal horizon. We live on Jupiter. And we have a very broad spectrum of looking out forward. 2023 is a goal year. While many of the people who are doing the most important work, and by that I mean actually achieving applications with supercomputing today, they're living on asteroids. And their horizon, is not much further than their functional or market nodes the next quarter. Both of these are valid positions. When they need to be engaged to help influence and project the trajectory of the levels of work in hardware and software, in tools and application algorithms, they will engage if they see real progress, real effective progress. If it's just a set of slides, they will pay as much attention as that deserves.
I just wanted to mention that, so I did go to the update yesterday, and there were 200 so far responses to the RFI. You probably heard that already. And there were only 8, I believe, from industry. And so they were saying they would, hold things open, inviting more responses now, recognizing that was not especially good. And again, I don't want to take too much of your time, but I did want to ask a good technology question, which is, looking at the program, what technology would you like to see tackled first? And maybe that's the wrong way to put it. What technology do we need to see progress on first that is a rate limiter that we really need to sort of address, or we won't get any place?
Oh, there are so many possibilities there. So the one I'm going to mention really is dealing with the data and I/O. This is a place where the existing systems are actually surprisingly poor. Just at the moment when one of the greatest opportunities is better integrating data into the scientific workflow process. And so we've got big problems in software and algorithms and memory and processor. I think that the management of data and part of this convergence that is mentioned in NSCI is one of the ones that is not receiving enough attention or effort, recognition. Even our application users are horrified, more than surprised, at how bad the systems are currently.
So your viewers may not be satisfied by my answer, but let me take an orthogonal perspective. And I'll call it a technology, but it's not what they're expecting. What I think is the biggest challenge, and I may be a minority of one, is the actual paradigm by which we're doing computing today. And I have argued that we need to learn again, as we have learned in the past, for specific technology pivot points, what is the best methodology, the best paradigm for organizing parallel computation, and to address such problems as parallelism or starvation, the latency problem, which relates to the data movement problem, and I agree with Bill. But for those of us in the trenches, we look at the overhead. We measure the microseconds or even nanoseconds, and the problems of contention, including bandwidth of communication, but also other throughput concerns. With that, it conveys to us, it informs how, in fact, we might be programming, not leaving the past practices behind, but embellishing or expanding on those practices in what I would believe is a more complete, and this is a critical issue, the more unified approach. So if I saw an advance in the total space of and supercomputing and exascale computing, it would be the reunification of what is today ensemble computers back to a point 20 years ago, 30 years ago, Seymour Cray and others, in which we're again looking at a single computer, one computer, not thinking of it as the masses of separate computational elements, which should make programming easier, should make efficiency superior, and of course provide us with the scalability. From the lowest level technology, I have a preferred one. I don't know if it'll ever happen. I'd like to see logic migrate more effectively into the memory chips, a concept that goes back to 1990 plus or minus before, sometimes but not always called PIM or processor memory. But there'd be a technology I think could advance certain efficiencies and concurrencies well.
Well, thank you both for your time. I know you have tight schedules, and I think we should do this again maybe in 6 months and see what's happened. The plan will be, clearer then. We'll know what's happening. Monies maybe.
Germany?
We could do it there. That's a great idea. Yep. We should do it at ISC. Anyway, Thomas and Bill, thank you very much. I appreciate your time.
John, thank you very much. Bill, always a pleasure.
Great. Thanks, guys.
Thanks, John.